This is an introductory video explaining how to use Microsoft Excel. So what Excel is for is we use it to do calculations. So I can type in a formula here, and when I hit enter, Excel calculates the answer for me. So this will be very useful in the lab in that you can get Excel to do all of your calculations for you. You'll notice on the page you've got various little boxes. These are called cells, and each cell has a unique address. So this cell that I've clicked into is in column B, row 4. So its address is B4, and that is written up here in this little box in the corner. If I click into a different cell, it updates the address, A2. This will become relevant later on when we use the cell addresses in our calculations. Now right here, you can see the answer to the formula that I typed in. If you want to remind yourself of what you actually had typed there, you'll need to go up here to the formula bar at the top, and this shows you exactly what was typed into that cell. You can also click into this formula bar and make changes to whatever you typed in, so you can correct it if you need to. And when you hit enter, Excel has automatically accepted your changes. If you click into the cell itself, not into the formula bar, then as soon as you type anything in, it's going to overwrite whatever you had before. So the previous equation is now just gone, and it's accepted my new one. If you're halfway through changing something and you realize you don't want to make that change, just hit escape, and the program will automatically go back to whatever you had before. Now, when you're creating a spreadsheet for an experiment, you want to label everything well. So start by putting in your name and your partner's name, and it's also a good idea to identify the experiment that you're working on. You would also want to label your data well. And I'll just point out something that happened here. So I typed in distance and my units. You can see those up in the formula bar, but on screen down here, they've been chopped off because I typed something into the next cell over. So that happens pretty commonly, but you can change the width of these cells. One way to do it is to hover your mouse in between the two columns, click, and drag it to the new size that you want. Another trick that might come in handy is you can hover your mouse between these two columns, double click, and it will automatically resize to whatever was longest in that column. And if you don't like that, you can also click and drag it to the right size. You can, of course, also put numbers in, so you could type in your data. And now that we've got data, I can show you how to do calculations. So to tell the program that you're about to type in a formula, that is something that it should calculate an answer to, you just type equals. So that tells the program whatever comes next is a formula, not text. So I could type in 2 plus 10, hit enter, and it gives me my answer as usual. So for addition, it's the plus sign, and I'll click into the formula bar. And if you want to do subtraction, it's the minus sign. If you want to multiply, it's the asterisk, which is a little star-shaped character. So that's above the number 8 on your keyboard. So Shift 8 gives you the asterisk, also sometimes called a star. You hit enter, and the program interprets that as 2 times 10. So the asterisk is your multiplication sign. If you want to divide two numbers, it's the slash. So that's in the lower right-hand corner of your keyboard, and it will divide the two numbers. If you want to raise something to a power, it's the caret symbol. Some people call it a little hat. It's above the number 6 on your keyboard. So Shift 6 gives you this little caret symbol. Some people call it the hat, and the program is going to interpret that as 2 raised to the power of 10. So let's try that all again, except this time let's use cell addresses. There's a reason why, which I'll get to in just a moment. So instead of typing 1 plus 5, I'm now going to use the cell addresses. So I'll go equal sign to tell the program that I'm about to type in a formula. And then the cell address of this number is A4, and I'll add it to B4. I hit enter, and it gives me the expected number. So you can either type in the value, or you can type in the cell addresses. And there's actually a faster way to do what I just did. I can go equals, and then I just click the cell that I'm interested in, and the program automatically fills in A4 for me. I add a plus sign, click the second piece of data, it fills in B4 for me, and I hit enter, and I get my answer. So the reason why you would want to use cell addresses is you would like to avoid having to type in the formula every single time if you wanted to do that same calculation on every pair of data. And Excel gives you a way to do that. You can type in your formula once and then copy and paste the formulas into all the other cells. So there's two ways to copy and paste this. I'll show you the slower way first. First, you click into the cell that has the formula that you want to copy and paste, and you go up here to the clipboard on the Home tab and click Copy. That gives you this blinking outline. Then you can highlight the other cells where you want the formula to appear and click Paste, and the program will automatically fill everything in. Now if I look at this first one in the formula bar, it says A4 plus B4. If I click the next one, it says A5 plus B5. So the program is smart enough to automatically increment the cell addresses when you copy and paste down or copy and paste sideways. So like I said, there's two ways to do that, and the second way is actually faster. The second method is if you look at the highlighted outline on this cell, right in this corner here, you'll see there's a little square. If you hover your mouse over top of that square, the mouse changes shape, and then you can click and drag the box down, and it automatically fills in all of the rest for you. So that's a fast way to copy and paste all your data. So again, click on the cell that has the formula, hover your mouse over this little square in the corner, and just click and drag down. Now you'll remember that I said that the program was smart enough to automatically increment the row numbers when I copy and pasted downward. So my original function was A4 plus B4, and when I copy and pasted it down, the next line was A5 plus B5. There are certain situations where you would want to tell the program not to increment something. So let me demonstrate. Say I've got a constant, and say the calculation I want is going to be this number raised to the power of the constant. So that gave me the correct value here, but if I copy and paste down, I get a bunch of incorrect values. So what's going on there? Well, if I click here and then click into my formula bar, you immediately see what the problem is. It automatically incremented my constant, and I didn't want it to. So I did want B4 to become B5, but I didn't want F2 to become F3. So I need to tell the program, don't increment these values. To do that, you use the $sign. So I go back to my original formula. Instead of having F2, I'm going to have $F, $2. So the $sign just tells the program whatever comes immediately afterwards, don't increment it when I copy and paste. So $F means don't increment the F, and $2 means don't increment the 2. That's actually the one that's important for our purposes. So I hit enter, and now when I copy and paste downward, it gives me the correct values. So to prevent something from incrementing, use the $sign. So now I'm going to teach you how to type in some special functions. So Excel has these inbuilt functions that we will need to use every now and then. So for example, if you wanted to add up all of these numbers, you can use a function, equals sum, open bracket, and then I could put in each of these separated by commas, and close my brackets, and hit enter, and it adds them all up for me. I can also go equals sum open bracket, and then if my data is all in a block like this, I could just click and drag over it, and you'll see down here the program fills in B4 semicolon B8, which means all the values from B4 to B8, and then I can close the brackets, hit enter, and it again calculates the sum for me. So sum is one of the functions that you're likely to use. Another one is average. And again, I can just highlight all the data I want to be averaged, close the brackets, hit enter, and it calculates it for me. Another one that you tend to use in this course is standard deviation. So equals STDEV, open bracket, and again, highlight your data, close the brackets, and hit enter. Now all of those that I just showed you involved lists of data, but sometimes you also just want one value. So you might have equals SQRT for square root, and then your data value, just a single one, close the brackets, and it calculates the square root of that value. There's also trigonometric functions. So for example, I can go equals sine, open brackets, and then an angle, and I can close the brackets. But here you'll notice something a little unusual. The sine of 90 degrees is 1, so how come I'm getting some other value here? Well, Excel assumes that whatever value you give it is in radians, not degrees. So luckily there is a function that allows you to convert something to radians. It's just equals radians, open bracket, add your value, and then close the brackets. And now it's converted it. And you can actually nest these one inside the other. So you can go equals sine, open bracket, radians, open bracket again, then I add my 90 degrees, close both sets of brackets, hit enter, and now I get the value that I was expecting to get for the sine of 90 degrees. So just remember that Excel will assume that if you type in cos or sine or tan, that the value you're giving it is in radians. And if it's not, you should convert it to radians first. And by the way, if you need the value of pi, you would go equals pi, open bracket, close bracket with nothing in between, and then Excel gives you the value of pi. This part of the video is about some online resources that we have to help you in the labs. So chances are you're watching this video from a Moodle site. So to get these resources, you'd log into your Moodle site with your student number and your password as usual. And once you're logged in, you should see your dashboard, and you can scroll down and click on the appropriate lab section. So what I've done here is that for every experiment we're doing this semester, there's one of these clickable sections that you can go into. So I can click on this first one, and everything that we need for that first experiment is there. So I'll go down to a more typical experiment, like the uniform circular motion one. And the first thing in here is, of course, a video that you should watch before coming to the lab to help prepare for that week's experiment. And then underneath it, you'll see 3 more things. So the first one is a template spreadsheet. I'm going to show you this next. This will be what you do all your calculations in. The next thing down is what's called a formula checker, and I'll explain that after I've talked about the template spreadsheet. And finally, at the bottom, there's a link here where you can hand in your work electronically to your lab instructor. So let's open up this template spreadsheet for this experiment. Now, the first thing you see when you open this up is that you need to enable your macros. So just click this button that says Enable Editing, and you may see a second one that says Enable Content. Click that one also. Now, if you have a Mac computer, you're not going to see those little buttons. You'll probably see a screen that looks like this, and it's the same deal. You should click on Enable Macros. The next thing it'll ask you to do is to fill in your name and your partner's name. So you do that, and it's going to do 2 things immediately. One is that it's going to save your file to the desktop, and it's going to use your names as part of the file name. The second thing is that it actually fills in your names here. So then you're ready to begin. You can put in the current date for the experiment, and then if you scroll down a little bit, you see that there's 2 sections. There's a data section here, and then right below it, there's also a calculation section. Now, one thing you'll notice is that there is, for example, a hanging mass section down here, but there's also one up here. And why is that? Well, you're expected to do your conversions from grams to kilograms in the spreadsheet. So you could fill in your raw data here and your uncertainties here, and then down here you do the conversion. So you'd say equals this value divided by 1,000 to make it kilograms. And because the same conversion will apply to the uncertainty, I can just copy and paste sideways. And I will point out at this point that the spreadsheet looks kind of fancy, but it actually isn't. It's completely empty except for labels. In fact, the only reason we're giving you this is to save you the busy work of typing in all your labels. So you will have to fill in your data. You'll also have to type in all of your calculations. So I'm going to fill in the acceleration due to gravity now and do a calculation. And by the way, some lab instructors want you to use 0.01 meters per second squared as the uncertainty for the acceleration due to gravity. Other lab instructors will prefer that you use 0. So you should clarify that with your lab instructor. So down here, I can now do a calculation for the force due to the mass. So this is just going to be mg. So I'd go equal sign m times g. I can also fill in my uncertainty, and I'm going to purposefully make a mistake at this point because I want to show you something with this. So equals uncertainty of the mass times, and I'm going to type in the uncertainty of gravity, which is incorrect. It should actually be gravity itself. So I'll make a mistake in that formula, and I'll show you this editing mode. So you can click on a cell, and if you say to yourself, that number looks kind of small, did I make a mistake? You can double click on it, and it puts you into an editing mode. So you can actually change your formula right here, exactly as if you had clicked into the formula bar. Now, one thing that's nice about this editing mode is that you'll notice that it lights up the data with colored outlines and then color codes the calculation itself. So I can go and say, okay, B21, that's this one, and J11, that's this one. Oh, that's incorrect. That's not the right one. Another nice thing about this editing mode is I can actually hover my mouse over top of the colored outline on a box and then click and drag it to a new location, and my formula automatically fixes itself. So now I'm going to show you another useful trick, is you'll notice that on all the data and on all the calculations, there's this third box. This is the fractional uncertainty. So it's just going to be the uncertainty divided by the value. So we've got the opportunity to fill this in once and then copy and paste it everywhere in the spreadsheet. So I'll type in my formula. I go equals the uncertainty divided by the value, hit enter. And right now I've got this displayed as a percentage. I'll also show you how to change that in a moment. And now I want to copy and paste that to all these other locations in the spreadsheet, but they're not all lined up in one block. So how do I do that? Well, as usual, I'd start by clicking on the cell, click Copy on the Clipboard section of the Home tab, and then I'll click another cell where I want that formula to appear. And now here's the trick. Hold down Control on your keyboard, and you can now select other boxes anywhere on the spreadsheet. So I can select all the places where a fractional uncertainty appears, and then go Paste, and it fills them all in for me. Now, this right now, as I said, is displayed as a percentage. If you wanted it just displayed as a regular value, again, you can use this multiple selection trick. You would hold down Control, click all the cells where the fractional uncertainties are right now, and then up here, you can change this from percentage to general, and that writes all of these values as a regular number. If you prefer the percentage, you can just go back to percentage. So next I'm going to fill in this formula and its uncertainty because I'd like to show you a reason why it's useful to have these fractional uncertainties listed. So you're going to be using these fractional uncertainties later in what's called a precision analysis, but it's also useful for typing in your uncertainties. So the equation that we use to get this net force is this. So it's just going to be the mass of the trolley times the radius of rotation times 2 pi over the period of rotation squared. So I'll type that in. I've got all this data. So I go equal sign, mass of the trolley in kilograms, times sign, radius in meters, times sign again. And I'm going to put some brackets in here now. So I want 2 times pi, so 2 times, and remember to get pi, it's pi, open bracket, close bracket with nothing in between, all divided by the period of rotation. And then I'll close my brackets and square it. So caret symbol 2 to square it. So I hit enter and I've now got this net force. So next I'll type in its uncertainty, and this is where the fractional uncertainties will come in useful. So the uncertainty for this equation here is the following. So the uncertainty for this net force is going to be the final answer times square root, and then I've got all these fractional uncertainties in here. And by the way, this last term, I've done some simplifications because this was actually 1 over t squared. So after you do some cancellations, you wind up with this form. So this is what I want to type in here for my uncertainty, and this is where the fractional uncertainties I've already calculated are going to come in useful, because I'm going to need the fractional uncertainty of the trolley, for example, and I've already calculated that. And the fact that it's in a percentage won't affect things, so I can just use this value directly. So let me type in my uncertainty now. So equal sign, and then to begin with, it's just the final answer for the force. So I could just use this force that I already calculated. So I click that cell, times square root SQRT, open the bracket, and now I'm going to start using these fractional uncertainties. So I'm going to want the fractional uncertainty of the mass of the trolley. So I click there, and then I square it, plus fractional uncertainty of the radius of rotation. So that's this value here, square it, plus, and I want 2 times the fractional uncertainty of the period of rotation, so I'll put some more brackets in here, and I'll go 2 times fractional uncertainty of the radius of rotation, close that bracket, square it, close the second set of brackets for the square root, and that's my final expression. Now the last thing I'm going to show you is scientific notation, and then we'll move on and I'll talk about the formula checker. So with scientific notation in Excel, if you've got a very large number or a very small number, so for example, 5 times 10 raised to the power of 18, that's too large for Excel to display in these cells. So what it does is it uses E to mean scientific notation. So 5E plus 18 means 5 times 10 to the power of plus 18. And you can use that notation too. You can just type directly 5E18, and the program will automatically interpret that to be scientific notation. Now, once you're happy with your spreadsheet, you can save it. Remember, it's being saved to the desktop, and close it. So the next thing I'll show you is this formula checker. What this is about is that we consider it a good idea for you to download your template spreadsheet ahead of time before the lab starts, and to fill in all of your formulas ahead of time. The only problem with doing that, of course, is that you don't have any data yet. So that's what this formula checker is for. If I open this up, what you see is that this is just that same template spreadsheet you have, except this has numbers in it. So anything that's typed in here in red is fake data. So it's intentionally chosen to be inaccurate. But any number you see here in black, that was calculated using the correct formula, which means if you take your template spreadsheet and type in all your formulas, you can then type in the fake data and check that you're getting the same calculated values as this formula checker is. If you do get the same numbers, that implies you've not made any mistakes. So using this formula checker is completely optional. It's just there so that if you do want to make your spreadsheet ahead of time and type in all your formulas, you can check that you haven't made any errors. And so the last thing I'm going to show you is electronically handing in your work. So if your lab instructor wants you to hand in your work electronically, you'd have a link here to do so. So I'll click on that link, And when you get to this page, there's some instructions here at the top that you should probably read. And if you scroll down, it gives you a button where you can add a submission. So I'll do that now, but first I'm going to minimize this window so that you can see the file that we created. So this is it here on the desktop. So now I'll click the Add Submission button, and that takes me to a screen where if I scroll down, there's an area where I can drag and drop files. So I'll grab this file that we created, and I'll drag it into this area. And if you had more files that you needed to submit, then you drag them here as well. So you might have an Excel spreadsheet, a typed report, perhaps a graph made with the line graph program, and even photographs of your lab notebook pasted into a Word document. So once you have all the files that you want to submit to your lab instructor dragged into this area, then you can click Save Changes. Now it's not quite submitted to your lab instructor yet, however. So right now it's in draft mode. So I'll scroll down a little bit, and there are the files that I submitted. And if I decide that I want to change something, I can click this Edit Submission button and delete files or upload new ones. When you're sure that you've got all of your final copies of your files, then you click this button down below, which says Submit Assignment. So once you've clicked Submit Assignment, it is submitted to your lab instructor and you can't make any more changes. So I'll click Submit Assignment. It asks me if I'm sure. I click Continue. And then scrolling down, you see that it has been changed from draft status to submitted for grading. Now, if you realize at this point that you've made an error and you do want to change things still, you can email your lab instructor and they can revert your submission to draft status very easily. Now, two last things. The first one's probably the most important, and that is that you should always delete your files off of the desktops on the lab computers before you leave the lab room. This is for your own protection. I've actually had students in the Thursday section, for example, plagiarize from students in the Wednesday section because the students in the Wednesday section had left their files on the desktop. And the rules at KPU are such that it doesn't matter whether you provided the file or copied from it, everybody gets a 0 and gets written up to the dean's office. So for your own protection, always make sure that you delete your files off the desktop before you leave the lab room. And the last thing I'll note is actually for your lab instructor's benefit. Your lab instructor is likely going to be juggling a lot of different files if they're having their students hand everything in electronically, and it really helps if you use your name and your partner's name as part of your file name. So for example, you can identify the experiment, uniform circular motion, then put in you and your partner's names, and then identify it as a notebook file or a spreadsheet file or a graph file or whatever. So as I said, this is mainly for your lab instructor's benefit. Deleting your files off of the desktop, however, is mainly for your benefit.